Hello, my name is Ibana Wotu, and today I'll be talking about how I made this custom esp32cam. I wanted to make a PCB, and I knew how to do it on paper, but that gives 0 XP, so there was not really much to it. With little thinking given to it, I decided to make an esp32cam with a screen and serial communication built into it. I'm sure there's a reason it's not included in the regular esp32cam, but I was just not a fan of programming with pin headers every single time, so that was that. I went online looking for schematic and data sheets, trying to find similarities and come up with a game plan. I found this video by Tech where he basically did what I wanted to do, so that was a big plus for me. So with all that, I kind of had a game plan together, so I jumped straight into KiCad. I'd already seen a ton of schematics, so making the schematic was easy work. To source for components, I used AliExpress. I know I could have used LCSA Electronics, but I did the math and AliExpress was just cheaper considering shipping to my area. For the PCB layout, I didn't want to think so much about it, so I just used a similar layout as the one he used. Some components weren't available, so I just found viable alternatives and adjusted their footprints when needed. As for routing, that was a tough work, and I'm not going to start explaining all that explanation, I beg, it's just drawing. When I was finished with KiCad, I just left it for a couple of days to marinate.
Yeah, boy.
I occasionally reviewed it to be sure I didn't screw it up. As a PCB manufacturer, it was either PCB way or GLC PCB, and I just chose GLC PCB because overall it was cheaper from production to shipping, and all I could do now was just track it. Since I was waiting for the package to arrive, I had some free time, so I decided to do most of the software. The camera software was readily available online, so there wasn't really much to do there. But for the screen, I found this guy Upe, and after watching this video, I instantly knew I want interface. So I made a custom interface for my application, and it wasn't that difficult since this video gave a step-by-step guide on how to get it done. I wanted to add games to it, so I did a little research and decided to add Flappy and Pong. And the code for both of them were available, so the rest of it was just cakewalk and editing it to do exactly what I needed it to do. I also added a YouTube and Wi-Fi menu. The YouTube menu was just going to be a QR code you'd scan to watch this video when it gets uploaded, and while the Wi-Fi menu was just a static IP and password to view the camera stream. The software was just basically mixing all these functions together without getting any errors. I did majority of the testing in Walkway. I used Walkway because I didn't have the boards in hand and it was just the easier and better option to use. In about a week, I was done with most of the software, so all I had to do now was just wait for the PCBs to arrive.
Many months later.
Turns out the package was lost in transit, so I got set back by 2 months. Well, it was an easy fix, I just needed to pay a little extra to reward that we upgraded shipping.
2 weeks later.
Yeah, I was excited and all because it looked sick, but I had to assemble it to be sure it actually worked and I didn't just make trash. So I did a continuity test and it was promising, so I just went straight into assembly. It did not work. It did not work. I found the problem was 3.3 volt and ground plane were bridging. I tested all the components trying to find faults. I found nothing. I checked it again. I still did not find anything. I even made this DIY microscope on my phone to get a close-up. I still did not find anything. After a while, I decided to do another one.
Here we go again.
And this one had to work because I was running out of components and I had to be really careful. So I was a lot careful with this one, and this time there wasn't any bridging, so it was pretty much just smooth. I wasn't getting any serial communication. I checked for all the possible causes, and there was a good list of things that could have gone wrong or I didn't do right. So I just went screw it and made breakout pins for the UART communication. Did that solve the problem? No. No.
Oh Lord. Again. Again. Nothing new, nothing changed, same old shit.
At this point, I was just weak because I still wasn't getting any communication. I did the research and found out the module was probably faulty. Maybe it was just cheap and didn't work, or it went bad because of overheating from the hot air gun. Either way, I had to replace it, so that's what I did. It finally worked.
Nice.
So I went straight into testing and uploading, and it worked like a charm. Since I was sure this one worked, I went on to install the camera connection and did some more inspection to be sure everything was a-okay. For the camera, I just used the basic stream code where I just streams video to the web page without all those fancy features and buttons and clicks and all those stuff, because it was less bulky and was a lot easier to work with. And after installation, you have some sample photos. Unfortunately, that was kind of short-lived. I don't know, the camera got damaged. I don't know the kind of manhandling I did it, but at least I knew they all worked together. The two games, Flappy and Pong, were written in different libraries, so that was giving errors because the display drivers were clashing. The only solution I could think of was writing the Pong game in the library used for the Flappy Bird game. It behaved really wonky at first, but after some tinkering, I just got it to work. The vertical pin headers I initially used for the UART communication quickly broke off, so I just switched to the horizontal ones, which were just better because it reduced the overall height of the board. Which is also the same reason I soldered the OLED display directly to the board instead of using female headers. It was also just to reduce the overall height of the board. For the card work, I wanted to use Onshape because that's what the cool kids are using, but it took time getting used to, so I just stuck with Fusion 360. 3D printing took an embarrassing number of trials, mostly because the filament I used was wet, and I was trying to get the best result, but there was no helping it. The filament was just too wet. I just went with the best looking one. I didn't even think about it. To power it, I didn't want to use a USB cord all the time, so I came up with this magnetic power bank kind of thing with my old headset battery, this charging regulator, pogo pins, and magnets. I don't want to go into much detail, but this was basically what it looked like on the inside. Basically, the way it works is the power pack and the case magnetically attached to each other, and the pogo pins align, and that is how power is just transmitted. Basically, that is just what it is on that. You've probably noticed, but I placed an NFC tags inside the case or 3D printed case. The plan was to patch the NFC tags with the link to this YouTube video when it gets uploaded, and also to patch it with the GitHub repo for this project. And that is it. Basically, months of work crunched into a couple of minutes. There really isn't any use case for it. It's more of a proof of concept to get extra XP. And I really left a lot of the details. So if you've got any questions, you can just leave them in the comment section. And that's all. That's that. So thanks for watching.